We'll be talking about some things this morning, and those things we'll be teaching this morning will actually be on i18D edges and plane interactions. We heard from the beginning that there tends to be what is known as dimensioning, 3D dimensioning, and we know definitely that one plane is about 3D dimension. 3 dimension is one plane. And one plane is about this place. From all here to this place is one plane. But this one plane interacts with other planes. And these other planes actually has a compulsory edge attached to the new edges. So when we look into this, we can tell that one plane is equals to 3D. And then 6 planes is like a Ludo dice, like 6 planes is equals to 18D. That's 6 multiplied by 3. That's 18. And we understood definitely that these planes are interactive, that they interact with one another. And the interaction is really beautiful because when it interacts, there tends to be a movement of the planes. That is how 3D animation came out, through the movement of the edges. For example, this is a 3D surface. This is just the surface, a 3D surface, and you have 4 edges there. And these edges, when they interact or go through a meshing product system or a mesh interactive system, there tends to be a movement, and that movement is what is called 3D movement. But since we have i18D, which is 18 dimension, we can actually say something. These 6 dimensions, on these 6 planes multiplied by 3 gives us our 18 dimensions. There tends to be some qualities that are attached to each of these edges or these points, and we can see the line of a wave there. And this line of a wave can either be side cube edges, eye hair cube edges, smell cube edges, taste cube edges, and touch cube edges. And all these are related, or they are part of the modular system. And we understood definitely that there is an interactive modus between the edges of the points, and when they interact, actually there tends to be a movement. And we understood definitely from what I said earlier that we have waves, that each of the edges or points gives waves, and these waves tends to be in the format of eyesight, eye hear, eye smell, eye taste, eye touch. For example, if you have an object, and this object, and you want to touch this object, most of the time we carry objects through their planes or through their edges. And so if you've carried something through the plane or edges, you understand definitely that these edges can either be touch waves, sight waves, hear waves, smell waves, or taste waves. Like when you have something in your mouth, there tends to be a movement, and that tends to be a dimensional movement as a result of the properties of the edges or points. Each edge tends to possess something that is known as spatial interaction, because each edge contains some particles, and all are made of atoms, all are made of particles, and these edges tends to have some spatial interactions and spatial properties. And the spatial property tells us that they are what? Atomic. Well, not a bomb, but they have atoms. And these atoms have neutrons, electrons, and protons. And there tends to be a movement of the electrons and protons and neutrons in different formats. And when they react and move in different formats, there tends to be a property that's associated to this. And we can understand that this particle that made up these edges or made up these planes, they tends to interact. And in a special interaction, we can understand that the waves that comes out from these particles or substances are the ones interacting with one another. It is a beautiful world of interactions and animation. We understood that we also have something that is called meshy cloud interactions. And this meshy cloud interaction is an interaction of the planes or an interaction of the edges. For example, if we take this 3D format or 3D plane now and look at these four edges. These four edges are tied together through a meshy cloud interaction and an interactive mode where these four edges interact. So in 3D, there's an interactions, and these interactions are what are the foundations for animation, the movement of the planes. But here we have i18D, and we have 6 planes and 18 edges, and these planes tends to undergo what we call meshy cloud interaction, where they interact. This will interact with this, this will interact with this, and this will interact with this. You can see a triangle here, a triangle here, a triangle here, a triangle here, and all this forms a cube planar surface, just one planar surface. And when you look at all this, definitely you see that I have blue here, light blue, red, and green. All these are interacting. If we want to talk about color interactions, these colors are actually interacting. But we are talking of particles, and we are talking about motions, and we are talking about substances and atoms, protons, neutrons, and electrons. They tend to move from one point to the other through what is known as spatial interaction. We have different types of edges. We have cubical edges, we have straight edges and dumb edges, and we have round edges. All these are made of particles, but they tell something on the wave property of the edges. If the edges are round like that, it might not be pointed. You might not have a well-distributed animation. But if they are pointed, you might have what they call a distributed animation. And then we understood something, that in each of the planes, these are actually the plane, the 6 planes, and the 6 planes, they tend to have edges connected. This edge and this edge here and this edge is the formative edge of the second, and this edge and here is the formative edge of this other plane. So each plane has one perfect plane, that's three perfect sides, and one side attached to the other plane of the next surface or plane. We can understand definitely that we have something here that we wrote here, like the I transfer, I edges, I movement, I animation, I plane. We understood that I transfer, we can transfer things through the planar surfaces because they go through movements. For example, if you have a car and you want to see the edges of the car or turn the car up, down, you can use i18 edges, because what you have to do is to accelerate the neutrons or the electrons or the protons that are responsible for the edge for each edge movement, and then through calculations and through softwares we can alter them. We can alter the movement. We can take this cube up, bring this cube down, take it to the right. We can flip it up and down. So in this present dispensation, there is that property that we can spin the car upside down and look at the car, and this is beneficial, good applications for mechanical engineers, automobile engineers. They can turn the cars, look on top of the cars, look behind the car, look to the side of the car, under the car. And this is a typical illustration of I18D is really vital in our lives. This was actually coined, this was actually created by Aliyo Momot. And it's really it's really an interactive process where you understand so many things about modular, and there are powers and everything lies to it that is connected to these edges. We are going to talk about eye edges. We saw eye edges, eye movement, eye animation, eye place. This is what is called the modular switchboard. And then we have so many beautiful things about this. Like we talked about meshy clouds, interactions, spatial interactions. We talked about the planar surface movement known as animation. We've talked about the edge wave. The edge wave have some properties. There tends to be an intermittent space here, an intermittent space here. And this intermittent space, after a movement of waves, there tends to be an intermittent space. And this is where you have the domain, and this is where you have other properties like animation properties. The animation properties exist in this domain, and when one object, when you pull an object, or when you pull an object like this, it flips. Why it flips is that there tends to be an even animation that is in the physical world, not in the software, in the physical world, that moves the object from one plane to another plane. So with the domain property here, and also the other properties that lies in the intermediate space, there tends to be a movement of such planes from one plane angle to another plane angle. Talk about some things. It's really beautiful when you know that there's a link property between the eyesight, eye hear, eye smell, eye taste, eye touch. And these link properties are interactive properties. So we are happy to know something that planes and edges does interact, or they do interact. And we can tell accurately that these planes and these planes and these edges are beautiful animating formats or spheres. And we can understand definitely that when they interact, there's a beautiful movement. Summary. The summary goes like this. These are edges, points. These are planes. This is a plane. And the edges in a cube is 18. And why it is 18 is that one plane is 3D, 3-dimension, and 6 plane is 18 dimension. And these edges or points, they do interact, and they interact with the planes, and the edges and the plane and the edges and all the edges do interact, and that is what is known as i18D edges and plane interaction. Thank you. Bye bye.